All right, this is a short one, 30 minutes. So we're going to get started right away. Thank you everybody for taking the time to join our presentation today. I'm Elaine Kwok. I am our Senior Director of Marketing at Peak Power. And if you are not familiar with us, Peak Power deploys, operates, and optimizes battery storage, grid interactive buildings, and electric vehicles using a single software platform for customers and our partners to pursue net zero goals, cut operating expenses, and unlock new revenue opportunities. Our technology transforms large commercial buildings and industrial facilities into the cornerstone resources in a decentralized electricity system. And our creative financing approach is designed so our partners make money to be that energy resource. In the end, we all get cleaner, more reliable, and more affordable electricity. We've got 4 fantastic presenters that will be taking you through the development process for battery energy storage system projects. If you have any questions during the discussion, you can drop them in the Q&A feature that's just at the bottom of your Zoom screen. And while these questions are coming in, we would love it if you would upvote other people's questions, and that'll help us prioritize the questions at the during the Q&A portion. If you have any questions at all, just drop them in the chat. If you have any questions about the webinar, but if you have questions about the content, please put them in the Q&A. And from there, I am going to go back to our presentation, and I am going to introduce Archie Adams, who is our BD, our Director of Business Development at Peak Power.
Great, thanks, Elaine. So I'll invite our presenters here to provide a quick intro to themselves and their company's roles in the development process, starting with Pooja, and then Jocelyn and Chris.
Thanks, Archie. Hi, everyone. Pooja Shah here. I'm a senior consultant within DNV's Energy Storage and Emerging Technologies Advisory. I lead owners engineering work for battery energy storage. If you're not familiar with DNV is an independent expert in assurance and risk management, and we are a trusted voice for many of the world's most successful organizations. We use our knowledge to advance safety and performance, set industry benchmarks, and inspire and invent solutions to tackle global transformations. Within energy storage, my team does work from technical specification development to bid evaluations to conceptual designs to commissioning. I'll pass it on to Jocelyn.
Thanks, Pooja. I'm Jocelyn Zuliani. I'm our energy storage lead at Hatch. Like DNV, we're an engineering consulting firm. With Peak, we work on the project development phase, so from site assessment through permitting, CIA type applications, and detailed engineering. But our team also works across a range of energy storage projects, from concept all the way through owner's engineering and delivery. I'll pass it on to Chris for his intro.
Thanks, Jocelyn. Christopher Yee. I'm a project manager with Peak Power. We've worked on these projects from origination all the way till they get to operation. We've built projects across Ontario and across the North American states. So I'll pass it over now to Archie.
Thanks, everyone. Again, my name's Archie. I sit here in the Northeast and focus on the New England and New York markets. We're developing behind-the-meter energy storage projects and then optimizing the operation of existing energy storage projects. So if you go to the next slide. Looking at this agenda, we're going to talk about why we're interested in these behind-the-meter projects, the technology selection for those, developing our use cases. I'll speak about revenue generation and how we kind of create a proposal and what that means to the customer, and then project development and procurement and construction considerations. Before we start the Q&A, sorry, I think we have a quick turn it over to Pooja to present the why of behind the meter.
Thanks, Archie. So because this webinar is focused on behind the meter, I wanted to start with a quick definition of behind the meter systems and also help you understand why behind the meter systems are becoming more popular. Behind the meter systems are storage systems that are located at customer sites. They are typically connected to the distribution system on the customer side of the utility service meter. Why behind the meter? Three main points: bill savings, reliability and resiliency, improved power quality. And I'll talk a little bit more about these in the coming slides, but to quickly give you a high level overview of why behind the meter, it's often used to reduce energy bills by demand charge reduction, so lowering the maximum power consumed, and also energy arbitrage use case, so shifting electricity consumption from high to low energy cost periods. This will typically depend on what a customer pays for electricity, and it will also depend on what they are paid for export, so the sell rate. Another reason customers commonly use behind the meter systems is because they may be interested in having reliable access to power after disruption to the grid, particularly if these disruptions or outages are common occurrences, it's the customers face too steep consequences for interruption in supply. So for example, in case of a hospital. And one more thing is that it's also becoming a more viable alternative or complement to traditional diesel generators, because they can reduce the size of the diesel generator needed, or they do not have to rely on fixed fuel supplies and can generate revenue while the grid is operational. Next slide. I want to talk a little bit about best technology selection and sizing considerations. Some of the things that will drive the technology selection and how the system is sized are, identifying all the relevant loads that are going to be powered by that system. Also understanding and identifying the use cases. I talked about some of them in the previous slide, but I want to dive into them a little bit further on the next slide, and give you a highlight of some of the common use cases. Another important factor is identifying the project site, whether the system is directly located on the customer side, or a power purchase agreement needs to be in place. Some of these will also drive the technology selection and the revenue generation, which some of my colleagues on this call will be speaking about. Identifying financing options is another thing that usually drives technology selection. And then it's very important to engage the utility early on to overcome some of the challenges that might come on the project in the future. If there's a good relationship between the customer and the utility, that helps quite a bit. Next slide. Use cases. This is probably one of the most important things that drives technology selection and sizing consideration, identifying the purpose of the behind the meter solution that is being used. Some of the common ones are peak shaving, demand charge management, time of use, energy cost management, used as backup power, and recently one of the upcoming emerging use cases is if there's EV fast charging on site, and it's being paired with on-site storage. To give you an idea of each one of these, peak shaving and demand charge management is something that a customer can use for smoothing of own peak demand to minimize the part of their bills that varies according to the highest power demand, and then reducing the overall cost for electricity service by reducing demand charges during peak periods specified by the utility. For time of use energy cost management, it is where the charging of the behind the meter system happens when the rates are low, and the battery is discharged during peak times with the aim of reducing utility bills. We talked about backup power and outages a little bit, but continuity of energy supply is key, and it is the ability of the behind the meter storage system to substitute the network in case of interruption and reducing the damage for the consumer in case of blackout or outage. Electric vehicle fast charging, that's the integration of the BESS system in parallel with DC converted grid supply for charging of electric vehicles or other electrification vehicles by DC peak loads. I will now hand it over to Archie for a quick overview of revenue generation through behind the meter systems.
Thank you. That was a great setup to explain each of those. And now I can talk about sort of how we create what we call the value stack, where you're taking these different potential for revenue and understanding how you prioritize those in order to maximize the returns on the battery in the project. So demand response, there's a lot of value there. That's the storage is called by the utility and then dispatched typically during those system peaks. And so those are not occurring too frequently and really high value. Demand management comes in kind of different shapes depending on your utility bill and tariff. There's definitely some value that's pretty regular, and P-Power has a lot of experience doing that across several markets. Coincident peak shaving, I know up in Ontario, you guys have the global adjustment charges. There's a whole lot of opportunity for savings by forecasting and then dispatching the battery during those events. Here in the Northeast and New York, for example, there's the forward capacity market event, sometimes called the ICAP, and that's always the hottest summer afternoon. Everybody's turning on their air conditioning, and that's the highest demand on the grid. So the battery is dispatched to reduce the facility's load and generate savings that way. Sometimes in different applications, typically front of the meter, you can participate in frequency regulation, and then also provide reserves, either spinning reserves to help stabilize the grid. So understanding the project and where it's located, we kind of put those together, understand the profile of the project and how much it can make. If you go to the next slide. So understanding, looking at the bills, as I mentioned, pretty important to inform. You understand how you're paying for power today, both from the supply and the delivery side, and then understanding what we can do with the battery to reduce your charges there. We're looking at your energy usage. So typically when we talk to a customer, we're asking for bills and also looking for we call interval load data, which is a breakdown of what the facility is demanding and using for power at every hour of the year, sometimes even every 5 minutes, to get some really good granular data. And then we're looking at the technical facility layout, understanding where a battery can go and where that can be tied in, and putting that together into a proposal. I think we're focused on energy storage in this session, but oftentimes we see it paired with solar as well. And so those, we get a PPA rate from solar offtake, and then a shared savings split or a fixed payment based on the revenue potential from the battery. I'll turn it over to Jocelyn here for project development.
Yeah, so after we have a project, there's a series of steps we would go through to formalize it and develop the project. As Archie mentioned, a key step around these types of projects, specifically for brownfield projects, is the site assessment, both looking at the physical siting and finding enough space for the battery, as well as the electrical interconnection. And because this is particularly interesting to project developers, we're going to dive into that a little bit more on the next slide. So after we've determined how we're going to connect the system, we would need to go through the connection impact assessment. This involves developing the initial interconnection design, an operating philosophy, and engaging with the local utility for them to complete an impact assessment. Depending on your jurisdiction, the operating philosophy is often a key piece here, so the utility can really understand how you're going to use the battery and study it appropriately in their system impact assessment. Other permits are also completed at this time and as we move through the process. These include engaging with the local fire department or fire authority to understand their comfort with the project, as well as any specific considerations that need to be integrated into your design. municipal engagement and site assessment. And here we've listed ESER, but it would be any sort of environmental permitting required for a battery. And then finally, we'd move into the detailed engineering and equipment selection phase. This phase, we would do a detailed design of the electrical interconnection, the balance of plant, as well as engage with the utility to understand what upgrades they need to do and make sure that our design considers those upgrades and that their design is progressing along. And then selecting the equipment, not only the battery, but the transformer, any interconnection equipment, communications equipment that's required for interface between the battery and the local distribution company. Next slide, please. So we'll talk a little bit more about the site assessment. And this is generally broken into two components, the physical assessment and the electrical assessment. With brownfield locations and industrial facilities, often determining where to locate the best requires some time. It requires coming to the site, looking at where there's physical space available to locate the battery. Should it be indoors or outdoor installation? Generally, the preference would be to have an outdoor installation. However, that's not always possible depending on the available land area in the region, as well as the proximity to the electrical room. Ideally, we would want to be close to the electrical room and the interconnection point to minimize any losses on the cable and costs. Other considerations include accessibility for maintenance, so making sure we can get around the asset, the battery, to get in there and do our maintenance activities, any replacements required, as well as site security. So not only do we want to consider security from employees and employee safety, but also public access. And at this point, it's really important to engage with your local municipality. We have seen some municipalities who request that the batteries not be visible to the public, so that you have to put slatting in the fence or, a solid fence around it. So understanding how these play together is really important. And then finally, fire safety. Depending on the industrial facility, the consideration here will need to be assessed specifically to the facility. Typically, you would want to have some clearance between the building, but there may be other jurisdictional or facility-specific considerations that need to come in. So after we generally sited the battery, we need to look at how we're going to interconnect it to the facility. Again, this depends on the age and the electrical room of the facility. Newer facilities may have spare breakers, which allow for an easy connection, whereas older facilities, we may consider a more formal upgrade required to connect the battery. So we'd want to look at the electrical room. Is there space in the electrical room for the necessary upgrades? What are these costs? As well as ensuring that our connection point is ideally as close to behind the meter as possible in order to maximize the benefits and maximize the load we can offset for the facility. So I'll pass it on to Chris now to talk a bit more about procurement.
Thanks, Jocelyn. So I'll be discussing the procurement and construction phase of the project. We would start this process by scheduling a kickoff meeting to introduce the EPCs and the consultants involved to the project host or client, the safety measures, the overall system design, and the scope of each stakeholder involved will be discussed. At this stage, we can establish a main point of contacts from each teams to facilitate the chain of communication. Peak Power provides the necessary support to ensure that the project reaches the final completion within the agreed timeframe, while minimizing the interruption of the facility's normal operation. For instance, we typically schedule shutdowns to be completed on the days we would accommodate the project hosts, typically after work hours or even on weekends. We would also try to work with the clients if they already have a shutdown scheduled, such as annual maintenance work. In terms of procurement, long lead items are ordered a few months ahead to make sure that they reach the site on time. We ensure that the construction crew has already been mobilized to site and are ready to receive the equipment. Those long lead items include the battery energy storage systems, transformers, switch gears, breakers, and instrument transformers. The construction, installation, and commissioning activities are carried out by our EPC. This would include a shutdown to tie the battery energy storage system to the building's existing electrical infrastructure, the civil works required to accommodate the installation of large outdoor equipment, and finally, the installation of the remaining balance of system. All equipment are installed as per local building and electrical codes and standards. The engineer on record would complete the necessary testing and commissioning activities before signing off on the system. Additionally, the authorities having jurisdiction will review the final design and reports before officially providing the connection agreements and authorization to generate. At the end of the construction, the crew will typically do a mandatory cleanup, removing all unused materials and bringing the site back to its original condition. And this concludes the construction and procurement piece. I'll pass it off to Archie.
Thanks, Chris. So those are really helpful. Thank you guys for sharing that. Before we start the Q&A, we had 2 questions to help us get to know the audience a little bit better. The first one, what's your level of knowledge for battery energy storage projects? And then the second one is, what are your goals for a battery energy storage system?
This is also your opportunity, if you have any pressing questions, to put them in the chat using the Q&A function below, or to upvote any other questions that have come up. We've got a few of them here, so if there's any that you are particularly interested in, please upvote them and we will make sure that we answer in priority sequence.
Great. I think we have a bunch of answers back.
Oops, let me share the results.
There we go. All right, so a lot of folks are interested in the early stages and really the learning portion. And then the other end of the spectrum, we have somebody that's done a bunch of projects. That's great to see. And then in terms of goals, improving the savings and revenue, then both economic and environmental goals. So that definitely fits with a lot of what we've seen and a lot of what our focus is in conversations with customers. So thank you for that feedback. I think we have a few questions that have come in, and again, encourage folks to add more. So I'm going to start with a question from an anonymous attendee. What does the financial side of product development look like, and what are the options to owners? That's a great question. We actually, maybe I can refer you to our previous, the first of this series of webinars where we actually dive deeper into that, the financial side. But I think in a quick summary, there's sort of 3 main avenues for somebody that's looking at a project at their facility. They could choose to own that and buy the battery themselves and have somebody like Peak Power help on the development and operation. More typically, what we see is folks go with a third-party ownership model. So, for example, Peak can help you develop the project and offer that at a sort of no upfront cost, where we share in the savings from operating the project. So that's a no capital, no operations offer. And then less typical is a leased model, where it's typically shorter term, but you kind of see less of a payback from that. So again, I'm sure Elaine will share a link to that prior session, but that's the full answer there. And then a question about how long the whole process takes. Chris, can I ask you to field that question?
Of course. The whole process could take, depending on the size and the different LDCs and air authorities having jurisdiction involved, it could take between 8 to maybe 16 months. So it's different depending on the type of project and the different authorities having jurisdiction we're dealing with. Some may require more studies, some may require some additional permits to be reviewed, but we typically try and range between provide that range for our clients to expect the project to be going on to final completion and generating.
Thanks for sharing, Chris. And I want to give Jocelyn and Pooja an opportunity to chime in on any of these if they have any other notes to add on those.
Nothing on that one.
Sounds good. Yeah, Chris is all over it. Thank you, guys. Another question about revenue stacks and how those are different. So I mentioned, looking at a few typical revenue streams, and that we're kind of mixing and matching depending on the state, the territory, the needs of the customer. So that can vary. I think the question was, what's the best? Where to find the best ease of implementation of projects? It is a great question. I think there's sort of a few themes of challenges that come up. And typically those challenges are related to interconnection. We know that utilities are pretty busy with lots of interconnections coming into their queues. So I'd flag that as a big challenge. It is something that we can get an idea of as we're looking at the project and understanding how to mitigate those concerns. Let's see. All right, one more question here. We have a question about, does Ontario allow indoor battery energy storage? Any of the panelists want to take a swing at that?
I can start and then others can jump in. I think it would be, you'd have to look at the location specifically. I'm not aware of any overarching decree in Ontario that it can't be indoors. It's going to depend on the scale, the local fire department, local municipal codes. Project size will be a big defining factor, though. Obviously, if we're looking at a 2, 3, 4 megawatt hour battery, we're looking at a 40-foot container of batteries. That's probably not going to fit inside. But if we're looking at a sub 500 kilowatt hour battery, you could explore an indoor. I don't know, Chris, Pooja, if you have anything to add.
No, I would agree with your answer, Jocelyn. It's size dependent, and if you mentioned the sheer size of a 40-foot container actually getting into a building, you can imagine it'd be hard to get that in there, right? So a smaller system could be more promising. Pooja, did you have anything to add?
No, I think both of you covered it very well. Back to you, Archie.
Thank you, everybody. And I'll turn it over to Elaine to help wrap it up.
Thanks, Archie. So I wanted to thank everybody, all of our presenters for joining us today. And thank you to our attendees for giving us your time. If you'd like to learn more about the next step of the battery system process, which is all about operating the battery to maximize your value, please join us at our next webinar. It's on Thursday, June 8th. I will be popping this in the chat now, the registration link right here. And please be on the lookout for a post-webinar survey. We want to make sure that these are valuable for you. We want to make sure that these are fun for you as well. And we'll be building more webinars. So please answer that survey. That'll really help us a lot. Thank you again, everybody, so much, and have a wonderful rest of your day. Thanks all. Bye.